Okay, hello. We are trying something new this video where you guys get to see me write on an actual sheet of paper. So we'll see how this goes. Hopefully it works out well. In this video, we're talking about rotations. You can see on my page I have the definition of an order of rotation. So it's just the number of times a shape overlaps itself perfectly. So that's what that coincides means, overlaps itself perfectly. Another way we can say it is that it superimposes with itself, and that's just in a 360-degree turn. So how many times does the shape overlap itself perfectly in one full turn, one turn of 360? So what I have here is parchment paper. It's like see-through paper. You'll get this in class to use on all of your assignments and your quizzes, everything like that. You even get it on the PAT, which is awesome. So this is see-through paper that I'm going to draw on to make it easier to see the rotations for myself. So what I'm doing is I'm just overlapping the parchment paper with my image, and I'm just drawing the exact same shape on the parchment paper, making sure that my parchment paper doesn't move so that I get a really accurate representation of what this shape looks like as I'm drawing it out. It doesn't have to be absolutely perfect by any means, but you do want it to be a good representation of what the shape is so that you can really check to see if there is rotation. So I just drew the shape on my parchment paper. I can lift it up and you can see what it looks like. I don't really feel the need to color this one in just because I know all of the shapes are colored in, so that won't change much. So what I'm trying to find for each of these different pictures, I've drawn them twice. It's just because that was for my Smartboard lesson, but it's not really relevant here. But I'm just looking to see how many times this shape will overlap on itself in a 360-degree turn. So I've drawn this shape on my parchment paper so that I'm able to spin it around and see how many times it overlaps. And the other thing that I'm going to do, that's why I actually have this other shape here. It's the exact same one, but this time it has a little dot in the center. And that's going to tell me where to put my pencil so that I know how to turn my shape. Okay, so that's called the axis of rotation, is that little point. And I'm also going to put an arrow indicating the top of my rotation, just so I know when it's been 360 degrees. When that arrow gets back up to the top, I know I've done a full turn. Okay, so I've drawn my shape. I have my axis of rotation stuck in the middle, and I'm going to put my pencil on that so that I can hold the parchment paper down. And then I'm just going to rotate my shape. And you can kind of see the lines underneath in this video. And ooh, there we go. I've overlapped the shape basically perfectly. Okay, my drawing's just a tiny bit off, but it's almost a perfect overlap. So that's one time that it coincides. Okay, but my arrow's all the way over here. It's not back up at the top yet, so I'm going to keep rotating. Oh, and I get to about here, and I notice that it's overlapping my shape again perfectly, but my arrow's still not at the top yet. It's all the way down here. So far, we've had 2 times where the shape has perfectly coincided. And if I keep going, now my arrow is back up to the top, and sorry, my phone is going off. Now my arrow is back up to the top, and it's coincided again for a 3rd time. Okay, so then my order of rotation would be 3, because this shape overlapped itself perfectly 3 different times as it rotated around in a 360-degree turn. So that's why the parchment paper is really, really nice to use, because we can actually see when the shape is overlapping itself, since this is see-through paper. It's fabulous. Okay, so if I do the next 2, I'm going to use the same strategy. So I'm just going to outline my shape, make sure it's pretty accurate as to what it looks like underneath there. Then I'm tracing it really neatly. Whoops. And around like that. There we go. And I'm going to draw an arrow to indicate my start. And I have my pencil right at the middle. So I'm going to count for how many times this shape coincides with itself, superimposes over itself, overlaps itself perfectly. Okay, so here I'm starting the turn. It's not perfect yet. Still not perfect. No. Oh, Yeah, right here, there we go. It's almost a perfect overlap. Again, it's just because I'm not holding my pencil perfectly in the middle, but you can see that it's overlapping itself. So that's 1 because my arrow is all the way down at the bottom here. And if I keep going around, whoop, there's 2, and now it's back at the top where it originally started. So this one overlapped itself twice in that 360-degree turn, so I can put that my order of rotation is 2. And my last shape down here at the bottom, I'm going to do the same thing. So I'm going to trace my shape. Trying to get as accurate as possible, making sure I have nice, neat lines, and then putting an arrow at the top. This one, ooh, it doesn't give me a little point in the middle, so I have to decide approximately where the middle is, and we'll see if we can get it to overlap. Okay, here we go. Oh, that looks like it would if it was perfectly in the middle. Maybe I'll move it over a little bit. Yeah, so there's 1 overlap. If I keep going, whoop, there's number 2. Keep going, whoop, number 3. My arrow's still not back at the top yet, so that was 3. And then if I keep going all the way back to the top, there's my 4th one. So the order of rotation for this guy is 4. And there we go, I've done all the shapes. So the trace paper makes my life way easier because then I can just put the shape on top and actually physically see what is happening as I'm rotating my shape. So you get to use this, quizzes, tests, even the PAT, which is really awesome. So now we have another term. This term is called the angle of rotational symmetry, and it's the minimum angle required for a shape to rotate and superimpose on itself, so overlap itself perfectly. So what that means is that we have a little formula for it. Okay, so the angle of rotational symmetry is equal to 360 degrees, so that would be 1 full turn, right? And that's over top of the order of rotation. So if you know the order of rotation, then you can find out the angle of rotational symmetry. And the opposite is true. So if you know the angle of rotational symmetry, then you can rearrange this equation and find the order of rotation. So it works the same way. So in my picture down here, I have a little kind of plus sign shape, and there's this little line drawn on it so that we can see what happens as it rotates. This line isn't actually part of the shape. It's just to show how far we've rotated it. So in my second image of it, we've done a rotation of 90 degrees. So now that line is on the right side over here. So that was like a 90-degree rotation. And you'll notice that this shape is overlapping itself again. Okay, so it's that same plus sign. After a 90-degree rotation, it superimposes on itself once. Okay, so far we have an order of rotation of 1. Then if we keep going and we turn it another 90 degrees, so now we've done 180 from the beginning, and our line is now down here, so you can see how far it's gone, and we superimpose itself over top again, so it makes that perfect plus sign shape. So now this would be an order of rotation of 2. Then we keep rotating in this third picture, going around. You can see the lines over on the left side now, so we've gone all the way around to 270 degrees, and it's making that perfect plus sign shape again. So we have an order of rotation of 3 there. And then if I continue and go all the way back to that 360 point, then I'm overlapping my final shape from where it started. So that would be an order of rotation of 4. So that's my order of rotation for the full shape. So now I can figure out the angle of rotation. So the angle of rotational symmetry is equal to 360 degrees divided by my order of rotation, which in this example would be 4. So 360 divided by 4 gives me 90 degrees. So my angle of rotational symmetry for this little plus sign shape is 90 degrees. So all you're doing is you're finding out the order of the shape, and you're dividing to get your angle. So it's pretty easy calculation, at least, which is good. Now I have 6 more shapes that I'm going to find out the order and the angle of rotation. And then in a few of them, I'm also actually going to see if I have any lines of symmetry. So lines of symmetry is something that we talked about in a previous class or a previous video, if you've been keeping up with the videos. So what I'm going to do right now is just trace my shape onto my trace paper or my parchment paper. There we go. And now I'm going to put my pencil in the middle of it and see if I get any rotation. But I almost forgot. I'm going to indicate where my starting point is so that I know when I've made a full 360 degree turn. Now I'm just turning it. Oh, and it superimposes itself once, twice, and then a third back at its starting point. So its order of rotation would be 3. Then for the angle of rotation, I'm doing my formula, which is 360 degrees divided by my order of rotation, gives me my angle, so I get an angle of 120 degrees there. Lines of symmetry, so that's where we would have a perfect reflection between these. And this shape does not actually seem to have any lines of reflection. We can't do diagonal there, we can't do horizontal or vertical, no other diagonal, it just won't end up reflecting itself perfectly. So there's no lines of symmetry there. If I go to my next shape, I'll trace this one out. If you ever want to use a ruler on this, you absolutely can, but I think normally tracing it should be easy enough with the lines underneath there for you. Okay, oh, I always forget to put my indication, so when I know when I get back to the top, and I'm going to start rotating. So, no. Oh, if I had my point right in the middle there, that was one order of rotation so far. And if I keep going, oh, back up to the top, there I go, is my second perfect superimpose. So that was 2 total times, 1 down here, and then 1 more back up the top. So my order of rotation is 2. To find my angle of rotation, I just need to divide, and I get 180 degrees. And then my lines of symmetry, it looks like this one will actually have some, so I can draw them on. So there'd be a line of symmetry there. These are perfect reflections of each other on each side of the line, and then I have another line horizontally like that. Again, a perfect reflection from top to bottom. If I imagine a line diagonally, that one won't work because these points would have to be a lot higher, these ones would have to be a lot lower, so there's no diagonal lines of symmetry at all. So we only have the 2 lines all together. Then I can do my next shape. So this one, just tracing it with my parchment paper. Oops, there we go. And putting that indication arrow at the top so I know when I made a full turn, and I'm just turning that on the point. So nothing there, nothing over there, nothing over there. Oh, and I'm back to the top. So normally we always count the top position as part of the order of rotation, but if your shape doesn't actually superimpose itself until it gets back to its starting point, then we just say that there's no order of rotation, okay? So this only happens if you don't have any times where it's superimposing itself throughout that 360 degrees and it only overlaps itself back at its starting point. We don't count it at all. Whereas in these shapes over here, because we had an order of rotation, then we do include that starting point as part of it. Okay, so there is a difference. You really do have to keep that in mind. So this one has no order of rotation, not even one. Even though it overlapped at the very end, we don't count it because obviously a shape is going to overlap with itself when it's standing on top of itself, okay? The angle of rotation then is not applicable because we didn't even have an order of rotation, so we can't say we have an angle. And then lines of symmetry, well, I actually do have a line of symmetry horizontally, like that. There's no vertical line of symmetry, there's no diagonal line, so we just have the one horizontal line of symmetry. So the order and angle of rotation are always related to each other. However, the lines of symmetry might not be related to the rotational symmetry. So that's important to take note of. Sometimes you're going to get a reflection, sometimes you're going to get a rotation, sometimes you're going to get both, okay? So it just depends on the shape. Now I'm going to do my bottom 3. Draw this triangle. And put a little arrow so I know when I get back to the top. I'm going to try and place my pencil in the center. Ooh, there's 1. There's 2. And since it did have some sort of order of rotation, I can include the last one where it's back at the top, so that's number 3 for my order. And then if I'm trying to figure out the angle of rotational symmetry from there, I just need to do my 360 degrees divided by 3, which is 120 degrees. Lovely. Now I'm going to go to this pentagon over here, trace this shape, do the same thing, put my pen best I can in the middle. Oops, need an indicator so I know when I'm back to the top. And start to rotate. Oh, there's 1. Ooh, there's 2. 3. 4. I'm not even back to the top yet. Woo, 5. There we go. So that one had an order of rotation of 5, which is lots. Then for my angle of rotational symmetry, that would be 360 divided by 5, which I believe is 72. And the last one, my octagon over here in my corner. Oops, that was a little bit off. I moved my parchment paper and drew an incorrect line by accident. But it's okay because you can still erase it off. And put my arrow at the top, put my pen in the middle, and start to rotate. Ooh, this one's kind of tough to see. There was 1. There's 2 already. Ooh, there's 3. There's 4, 5, 6, 7. Oh my gosh. And 8. All the way back to the top, we did 8 perfect overlaps. So then my angle of rotational symmetry would be 360 divided by 8, which is 45 degrees. There we go. We're done. One thing that I found quite interesting about these 3 examples is that this is a triangle. It has 3 sides and it has an order of rotation of 3. Pentagon has 5 sides, order of rotation of 5. Octagon has 8 sides, order of rotation of 8. So we can have a little rule. If you have a regular polygon, and what I mean by regular is when, oops, that was probably out of the frame. Oh no, all of this is out of the frame. I'm sorry. I was writing that down and you can't even see it. Let me push this up. There we go. When you have a regular polygon, regular meaning, oops, and I'm still out of the frame. Goodness gracious. All sides are equal. That's what I mean by a regular polygon. So this is an equilateral triangle because all 3 sides are the same length. That's a regular polygon. If you have a regular polygon, then the number of sides is equal to the number, oops, equal to the order of rotation. Sorry guys, I'm a little mixed up right now. There we go. Okay, so to reiterate, if you have a polygon where all of the sides are equal lengths, like these ones are, then the number of sides that the polygon has will be the same as the order of rotation. So 8 sides, they're all equal, order of rotation of 8. 3 sides, they're all equal, order of rotation of 3. So that's just kind of a fun fact for you. Okie dokie, 3 more examples here. I already drew my shape, so this is my triangle. My instruction is to rotate it 90 degrees counterclockwise about the origin. So when it says about something, that's the point that you're turning it around. So in these examples, we're not going to put our pen in the center and rotate it like this because it wants us to rotate it around the origin. So I'm finding where the y-axis meets up with the x-axis. The point 0, 0 is our origin. So that's where I'm going to put my pencil. And I'm still going to draw a little arrow upwards so I know how far I've rotated it. So what I mean by that is right now, it's up at the top. I know that 90 degrees is that perpendicular side. So I know based on my arrow that if I turn it and when it lines up like this, that means it's gone 90 degrees because it's lining up with that line that's perpendicular to where I started with. So there we go. I literally already rotated it counterclockwise 90 degrees. And you can see that this is where my shape is overlapping here. So I'm going to kind of stick my pencil underneath my parchment paper and write down all the points that it went to on my page. So this one would be C prime. This one below is G prime. And the one up there is I prime. Okay, I've got all my points down, so now I just need to connect my shapes. You would be doing this with a ruler, which I don't have handy, unfortunately. And there we go, there's my new shape. So again, I'm just using my parchment paper to rotate it a certain number of degrees. You should know what 90 degrees looks like. Okay, it's that perpendicular turn, like a quarter of 360. Time to do my second transformation. This one, 180 degrees about the origin, so I want to find the origin way up here, okay, and also going to draw my little arrows so that I know when it's been the 180 degrees. So I'm going to start turning, oh, there's my arrow, completely the opposite direction. So that's been a full 180-degree turn from my starting point. And now I'm just going to put down underneath my parchment paper. Notice that I'm keeping a finger on it so that it stays in the right spot. And I can actually write down where those points are located. This part's honestly the trickiest part, is lifting up the parchment paper and knowing where those points are. But you can see them through. If you like really wanted to, you could probably poke a hole through the parchment paper and draw it underneath. That works as well. But as long as you just peel the side up, you can usually see where that point is supposed to be. So this one up top is G prime, over here is V prime, and down here is N prime. And I'm just connecting those points to make my triangle. Again, if you had a ruler handy, you would be using a ruler like we do in class. And there we go. There's my rotation. And my last one is way down here at the bottom. I have this little shape in this corner. Where's my origin? It says I'm rotating at 90 degrees about the origin. And my origin is right here. I'm also supposed to be moving counterclockwise about the origin. So instead of going this way, whoops, you can't see my fingers. Instead of going this way like a clock moves, I'm going to go the opposite way, counterclockwise. And start to rotate. Ding! There we go, already at that place. And just lifting up my parchment paper, but keeping it still and in the same spot so that it is easy to see where these points are underneath. Is that right? Yeah, there we go. So this was U prime, L prime, K prime, and Y prime. I'm going to give you guys a hint. In this class, the rotations that you do on a coordinate plane will basically always line up back onto the coordinate points instead of somewhere in the middle of them. So you can always put your coordinate points down on the actual grid, if that makes sense. So you're not going into a space in between the block, you're actually going to that intersection. Okay, so there we go. That was my last one, my 90-degree rotation counterclockwise about the origin. In this next one, I'm doing a 90-degree clockwise turn about vertex E. So I've already drawn my shape on my parchment paper. This time, they're giving me my rotation point as E. I'm still going to make a point there. I'm still going to draw my arrow so I know when I've made the turn that I need. And yeah, that's pretty much it. Now I'm going to do what I usually do. So clockwise is in this direction. So I'm going to spin my shape until it's hit 90 degrees. There we go. And I'm just going to lift up my parchment paper and put those points down underneath in the exact spot. I need to be as accurate as I possibly can. So I'm just peeling back the paper, but making sure that my parchment paper does not ever actually lift up. Or like move spots. Sorry, that was poorly phrased. And one thing that I haven't mentioned yet is write down the points on your parchment paper so that when you relabel it as A prime and B prime, C prime, D prime, E prime, etc., you know which is which, because it's really easy to get disoriented when you're doing rotation. So please make sure you're writing down those points so that you're relabeling your shape correctly, because that would lose you some marks if you labeled it wrong. Okay, and there we go. There's my rotated shape. Okay, the last thing we're going to talk about in this video, I know it's been a long one, I apologize, is rotating a shape at kind of a weird angle. So when you have a 90-degree angle, a 180-degree angle, 270 degrees, those are all really easy angles to rotate at. You should know where those are located. But if you get an angle like this one at 120 degrees, I can't just eyeball that and really guess where 120 degrees is. So what we do is we actually use a protractor. So I'm going to walk you guys through the steps of how this works. So we have the image. I drew it already on my parchment paper right here. So there we go, I've drawn it. Now I want to make sure that I draw an axis through the point of rotation. So my point of rotation is F. I've drawn my little point there, and I'm going to draw a full axis, just like a cross with an arrow pointing to the top, just like we normally do on my shape. That way I can tell how far I need to rotate it. So just like usual, we're going to draw that axis at the top. Step number 2 is to place the protractor on your axis with the rounding edge facing the direction of rotation. So if you have a counterclockwise rotation, you're going to face yours this way, which looks like a counterclockwise motion, so it's fairly intuitive of which way to place it. The other option of placing your protractor is the clockwise direction, so again, it actually is facing clockwise, so it's pretty intuitive of where to place it. So we are doing a counterclockwise rotation of 120 degrees, so I would need to place my protractor in this direction, and you can see my protractor on my page is placed in that counterclockwise direction. And what I'm doing is I'm just lining up my protractor with my axis of rotation right there at point F, and then I'm measuring where 120 degrees is. So I start at the 0 and go all the way up to 120 degrees, make a little tick mark there so that I can see where that is, and then I move on to my next step. So my next step after that is to remove my protractor and then just connect that line. So I only made that little tick mark before. Now I'm going to draw a straight line from the axis to the 120 degrees. You can just do that with a ruler. You're just extending the line all the way across so that it's really easy to see. Step number 4, trace your shape on tracing paper. So that's what I already did here. Remembering to mark the axis of rotation in the point of rotation. So remembering to put this little kind of compass here so that I know how far to actually turn it. That's important. And then the very last step is to actually do the rotation. So what I'm doing is I'm taking my parchment paper, I'm putting it over top, I'm putting my pen at the point of rotation just like I always do, and then I'm rotating my shape until my arrow gets to that 120 degrees, to the line that I've already drawn. And then there we go, I have my shape. So the only tricky part of this question is just the fact that you need to use a protractor to measure out how far 120 degrees is. But as soon as you do that, it's the exact same procedure that you normally use. You're drawing your arrow, you're rotating your shape, and you're stopping when that shape gets to the arrow. And there you go. Then you just relabel your points, and you have your rotated shape done for you.